So to get started in this course, let's take a minute and look at a few terms that are going to show up many times during the course of the semester. And so maybe to get started, what we'll do is let's use an example to illustrate some of the important terms that are going to show up in the course. So for our example, let's suppose you're a researcher and you want to study how many hours on average Augusta University students spend working per week at an off-campus job, which seems like a reasonable thing to study. Now, one big problem is it's going to be very difficult to actually get this data for every single Augusta University student, given that there's about 8,000 students at our university. And so the common problem in statistics is what we'll have to do is we'll have to try to get an accurate result and only study a much smaller group of students. So with that in mind, here are some terms that will show up many times during the course of the semester. So first of all, we want to make sure we know what the entire group that we're interested in studying is going to be. And in this particular problem, the group that we're interested in is we want to study the undergraduate population at Augusta University as a whole. So the group we're interested in is all the undergraduate students at Augusta University. And as we mentioned a minute ago, the problem is it's going to be very impractical to actually try to study the entire population or get this particular data about the entire population. And so we'll have to somehow construct a much smaller sample. And the sample is going to be those students who we actually study and for whom we actually gather the data in which we're interested in. And so in a second, we'll actually look at a few different samples. And I'd like you to ask yourself whether or not you think that would be a good sample for purposes of this problem, or that would be not such a good example for purposes of this problem. Before we get to that, another term that we want to make sure we know is in statistics, when we say statistical variable, we can think of that as the quantity that we're interested in studying. And the reason we call it a variable is the implication is that may very likely differ among individuals in the population. In particular, in this problem, if I were to ask 5 different students how many hours per week they work at an off-campus job, it is distinctly possible that I could get 5 different answers. So that's just emphasizing that there's going to be some variation in this quantity from individual to individual. As we stated, the variable in this case, and one important point, is this is going to be the number of hours per week each student spends off campus working. We don't want to say that the variable is the average total. So in this case, the variable is going to differ among individuals in the population. So the variable really is going to be those individual totals from student to student. Let's look at a few additional terms. When we talk about populations and samples, one very important thing later in the semester is in statistics, when we say a parameter, we're actually talking about a feature in which that we're interested in of an entire population. So in this particular example, the parameter we're interested in is we want to know the average number of hours per week that Augusta University undergraduate students spend working off campus. So the parameter, that would be sort of the true average value of the entire population. As we mentioned, it's going to be very difficult to actually calculate the value of a population parameter. So in this problem, we have to try to estimate what the value of this parameter is by looking at some sample data from those students who we actually do study. And so the term we will use for that is when we calculate this particular value from a sample of data, we will call that figure a statistic. So the idea is a parameter, that is some number or some feature in a population, and the statistic, that's something we can actually calculate by collecting a sample of data and doing whatever computation we're interested in. So the thing you should remember is a parameter talks about a population and a statistic talks about a sample is the key idea. And one other thing you should remember is in statistics, a very fundamental problem is how to actually estimate the value of a population parameter. As we indicated, doing so in this problem would be very difficult because you would have to track down all 8,000 Augusta University students and somehow figure out how many hours per week they spend working. That's going to be extremely difficult to do. And so what we use in general is we would use a statistic or a figure from a sample to try to estimate what the value of that population parameter is. And the typical idea is we typically use a statistic to estimate the value of a parameter. So as we said, let's take a minute and look at a few examples and take a second and ask yourself if you think those are good samples. And what we mean by good in statistics is that the sample is actually representative of the entire population, which is another way of saying that the sample closely mimics the population in every important way. Or another way of saying that is if we were to calculate the average number of hours that the students work per week in our sample, we would expect that to be similar to the corresponding figure in the population. And when you read the book, the technical term we would use for that is if you picked a good sample where the statistic basically will match up with the parameter, we would say that's an unbiased sample, or the statistic will be very close to the true value of the parameter. So that's our goal. And so if we can actually do that, we will say we have an unbiased sample. So take a minute and think about whether or not each of these samples are likely to be good samples. So one thing you could do is suppose you're the researcher and you decide to study students or you survey students who are walking into Allgood Hall, which is where our math department is. And let's say you do that survey at 5:45 p.m. on a Tuesday evening. So take a second, say, does that look like a good sample or does that look like not such a good sample? And you can even pause the video if you want to think about it for a second. And after thinking about it, I hope that you would identify one pretty big concern in this particular sample. The concern that occurs to me is if students are coming in at 5:45 on a weeknight, there is a pretty good probability or a pretty good likelihood that if students are taking classes in the evening, you would have to at least wonder if those students might actually be having a full-time job somewhere. And if those students are actually working a full-time job, well, those students are actually maybe working more hours off campus than sort of the typical run-of-the-mill student. So sample number one, I would have some pretty big concerns about this. And so there's a good chance that this would actually be a biased sample. So these students maybe are not totally representative of the Augusta University population. Let's take sample number two. So if you're an Augusta University student, most every student at Augusta University takes English 1101, which is freshman composition at some point. So it might seem like a pretty good idea that since pretty much every student passes through that course, you might want to study or survey all the students who are taking that course. So again, pause the video or take a second and ask yourself whether you think that would be a good or a representative sample in this particular problem. And maybe something you came up with, or maybe a concern you had, is you might have to worry about what the student population is in English 1101. And what I will tell you, or what you might have speculated, is most students take that course in their freshman year. And so it seems very likely that if you sample students in English 1101, you're going to get an awful lot of freshmen in that particular sample. And of course, we don't know. Maybe freshmen are completely representative of the population as far as how much they're working off campus. But we would, I think, have to worry a little bit that we've got a lot of freshmen in our sample, and so maybe it's not completely representative of the Augusta University student population. In any event, anytime you're going to be missing a great big portion of the population, which in this case we're going to be missing a lot of sophomores, juniors, and seniors, I think we would have to look at this particular sample and just wonder a little bit whether or not it's a truly good sample. Let's look at one more, and this one might be a little more subtle. So suppose you are somehow able to get permission from IT and you actually send out a survey to every single Augusta University student, which is something you could certainly do. And you just send them a survey link or just a brief question, and you'd like to ask the students how many hours they're working off campus per week. And this seems like a pretty good sample because you're actually reaching the entire AU population. So at least at its face, this looks like it might be a pretty good sampling technique. So again, pause the video for a minute or ask yourself whether or not you think this is a good sample or a not so good sample. And it turns out there are a couple of issues with this particular sample that we would be a little bit worried about. The first issue is just sending the survey out. Well, the students are under no obligation to return your survey, or even if they return it, to answer truthfully. And so a term that comes up an awful lot in statistics is we would say this is a quote-unquote voluntary response sample. And generally, whenever we collect data, voluntary response can be a big problem because we don't know if the students who are actually responding to our survey, if they're completely representative of the population. And further, we have to wonder what's going on with the students who don't return the survey. So any time that we have to prompt people to actually answer and they can decide whether or not to participate, that is sort of one thing we would always have to worry about a little bit in the collection of data. And it turns out there's another number of other things we would have to worry about in that particular sample, the way the data is collected, but we will worry about that in the next lesson when we talk about potential sources of bias in statistics. So that is all for lesson number 1. And so there's a number of terms you should know in here: population, statistic, parameter, sample, variable, and a couple of different forms of bias, like what we mean by a voluntary response sample. So those are some terms you should know. There is a variety of other terms highlighted in the book in chapter 1, but these will at least start us out so we can talk about statistics. And that is lesson number 1 for chapter 1. And when you're ready, you can take the next lesson in this chapter.